Hi there, this is exercise 3B.1. It's for flowcharts and pseudo computer code, which is basically a topic on algorithms in Year 12 discrete maths for further maths. And it's a nice little topic, but it's certainly got some things that we need to make sure we understand. Some of it is, I think most of you will have seen before, and other bits will probably be new. So first of all, flowcharts, or sometimes called flow diagrams. Basically, it's a picture which represents the steps that you need to make in an algorithm. There is certain notation that you need to be aware of. For instance, the stop and start commands are always within this oval shaped box. The rectangular boxes are often used for calculations or instructions of some kind. Um, and you may be tempted to think, well, it doesn't really matter. And to be honest, it doesn't. But just be aware that if you was asked to draw one of these, you may lose marks for not drawing the right shape around the box, which seems petty, but you don't want to lose silly marks. And the one that definitely does matter is the decision boxes, like question boxes, are always drawn in this rhombus shape, in this sort of orientation as well. So normally you come down from a previous instruction, you get asked the question, is y greater than 20 in this case? And if it is, you go this way, and if it isn't, you go down. I'm sure you've seen things like that. But the fact they're in this like rhombus or diamond shape matters. So make sure you look out for them. And always remember to, if you are label them, write yes and no, dependent on your question. So on that basis, we've got a flow chart here, and it says trace the following flow diagram for the input n equals 5. So if we just work our way through it, and then we'll be able to do it. So it says, first of all, read n, and n is 5. So that's done. F equals 1. Okay, F equals 1. Carry on going down. Is n equal to 1? No, n isn't. N is 5. So what does it tell me to do then? No, f equals f times n. Well, my f is 1, my n is 5, so I suppose when I times them together, I'll get 5. And I keep on going around. N equals n, take away 1. Well, my present n is 5, so if I take away 1 from that, I get 4. And I'm back to this box again, and you can see I'm just going to do this a number of times. Is n equal to 1? Well, no, it's still equal to 4. So no, so f equals f times n. So again, I times the f, the 5, by the n, 4, that's 20. And then it goes back here, take away 1 from the value of n. So now it's 3. And I can see I'm eventually going to think I'm going to do this 5 times. Is n equal to 1? No, it's not. It's equal to 3. So f equals f times n again. The 20 times 3 is 60. N equals n, take 1. Well, now I'm on 2. Is n equal to 1? No, I'm not. F equals f times n. 60 times 2 is 120. N equals n, take 1. Now I'm on 1. Back up to here. Is n equal to 1? Yes, it is now. N is equal to 1. So what's it tell me? Print f and then stop. So print f. F is 120. And now I can stop. What does this do? This is what B says. Now, in words, explain the purpose of this algorithm. Well, actually, what I think I've done is I think I've times a lot of numbers together. So I've times the 5 by the 4, then the 3, then the 2, then the 1. I think I've done this. Now, for those of you who haven't done any statistics, you may not have come across what this notation is sometimes written as. This is written as 5 factorial. Which is equal to 120. And there's actually a button on your calculator, but it's factorial notation. So factorial, that's what we're doing. And it's got this exclamation mark. That's the way you actually do it. You write it. Anyway, so that's that question done. You can see it's just a simple, what's the point of it? Not really much point at all, but we just got to get our head around and be able to follow the instructions and show the examiner that we've done it correctly. And what we did there was a trace, and this is really saying what a trace is. Now, a trace can be asked of us in terms of a flowchart, or if it's written in this pseudo computer code. And pseudo computer code is like meant to be a simplified computer code. We're not particularly bothered by the language, whether it's been basic or some new variant of C++ or whatever. All we care about is basically we understand what the instructions are, and we're going to trace through, which basically means at every stage of the working out, we're going to write down the values of the variables in our program. So let's have a go at this program. It says trace through this algorithm with n equals 3. I'll start off straight away, write n equals 3 there. Step 1, x equals 0, d equals 0, s equals 0. That's easy enough. 0, 0, 0. if x is equal to n. No, they're obviously not. One's 3, one's 0. So we will go to step 6 at that stage, but at the moment we're not. So because it's not equal to n, so we just go to step 3. X equals x plus 1. Well, x was 0, so we just add 1 to it. T is t plus x. All right, t was 0 plus the 1. So I'm going to write 0 plus 1 equals 1. And s equals s plus x squared. So presumably this is the 0 from there plus the 1 squared. And 1 squared is 1, so this is just 1 again. So it didn't make much difference on those two. Now go to step 2. Okay, so we go back to here. If x is equal to n, well, still isn't. I've got n is 3 and x is 1. So I'm not going to go to step 6. X equals x plus 1. That's now 2. T equals t plus x. Well, my t was 1. If I add my 2 on for my x, I get 3. And s is s plus x squared. My s is 1. If I add my 2 squared on this time, don't forget to square it, that's 4, which makes 5. Okay, I've done that step. Go to step 2. If x is equal to n, then go to step 6. No, still not. I've got 3 and a 2. So x equals x plus 1. I can see this is probably the last time I'm going to do it. T equals t plus x. So I've got a 3, and I have to add on my x, which is 3, which is now 6. And my s is s plus x squared, which is 5 plus 3 squared. 3 squared is 9, that's 14. Go to step 2. If x is equal to n, now it is 3 and 3. So now I go to step 6, and it just says print the values of t and s and then stop. So t was 6, s was 14, and I've stopped. There you go, I've done it. What does the algorithm find for a positive integer of n? Well, what did it do? It did 6 and 14. Look, I'll tell you what it does. For any n, and I think this is why they've used the letters t and s. So when I add numbers together like this, these numbers, for instance, this answer would be 10. These are called the triangular numbers. And the triangular numbers are what you get if you add different numbers together. And I think that 1, 3, 6. So my first one would be 1, and then I get 1 plus 2, which is 3. Then I get 1 plus 2 plus 3 equals 6. 1, 3, 6. You can see I'm getting the same numbers. So these are definitely the triangular numbers. And the other ones, I suppose I should say that you can write that as sigma x. It's the adding up of all the numbers. And the other one, I think what I'm doing is I'm going 1 squared. 1 squared plus 2 squared. I'm going 1 squared plus 2 squared plus 3 squared. Now, these, I suppose, if you keep on doing it, it's the sum of the square numbers. It hasn't got such a nice name, but the way you'd write it is sigma x squared. What would happen if the value of n is not positive? Well, if n is not positive, see, there's a stopping condition here. It says if x is equal to n. I don't think we'd ever, if say n was say minus 6, I don't think, because this is going to go up and up and up, I think it'd be infinite. Oh, I think we've already discussed in exercise 3a that would make it not a very good algorithm because it must be finite. So just bear all that in mind. 2 new functions then. We've got int and abs. Now what int does is it says if I have an integer, say, or even a non-integer, so if say I get a number 3.2, it says if x is bigger than 0, then int x is the largest integer that is less than or equal to x. So basically it rounds it down. So that becomes 3. And bear in mind, if I had 3.8, it would still round it down to 3. It doesn't round to the nearest like maybe we would round an integer. It just rounds it down. But it does say, by the way, if x is less than 0, then int x is the smallest integer that is greater than or equal to x. So, so for instance, if I had 2.4, but let's make it a negative. I think this makes it minus 2. And I've seen other definitions of this sort of variable to actually round it to minus 3. It goes down, but on this it's saying it's the smallest integer that is greater than or equal to x. So there you go. Minus 2.4 becomes minus 2. And now Abus does a slightly different trick. Basically, we don't like negatives sometimes in computers. Same way we don't like integers, decimal numbers. We want integers. Sometimes we don't want a negative number. So sometimes you might get minus 3, and you say, well, round that so that is just a positive number. So there you go, 3. If it was minus 3.6, I would call it 3.6. So it doesn't make it an integer. It just gets rid of the negative sign. If it was 2.5, it would stay as 2.5. That's not a problem. The only issue is if it's minus, it gets rid of the minus. So those are those two functions. Now, what I've got for you then is some examples, and I want you just to go through this and write down your answers. I'm going to do the same thing for you in a bit, and I'll ping my answers up. But I'd recommend you pause this so that you've got a copy of what I reckon the answers are. And here are my answers. I hope you agree with my answers. Look, just be careful of negatives here. You might potentially call this minus 7, I suppose. And I think these are fairly straightforward. It's the equivalent of the modulus function which we see in pure maths. So anyway, so let's carry on. Now I've got a couple of real exam questions for you. I've had to modify them because some of the rules have since changed, and the expectations of what we need to do and consider for the new further maths. But basically, they are now appropriate. So this says, consider this algorithm. Trace through the algorithm using the values a equals 10 and b is 1 to 8. And record the values of these every time they change. Okay, well, let's do that. And it says record the output in the print box, presumably, if you reach line 60. So input A and B, and they tell me what they say that's 10 and that's 1 to 8. Calculate C, and C equals B divided by A. So that's 128 divided by 10, that's 12.8. D is the integer of C, so that's just 12. Notice the 8 doesn't matter. E equals A times D, so I'm multiplying that by that, so that's 120. And then F is B minus E, so that's 128 minus, so that's 8. Okay, and it says replace B by the value of D, so the B 128 becomes 12. And now I'm on line 80 if B equals 0. Now B is not equal 0, it's 12. So otherwise go back to line 20. So if I'm not happy with, if I haven't got this 0, I have to go all the way back up here. Now what's it say? It says calculate C equal to B divided by A. So B 12 divided by A 10, that's 1.2. Find the integer, that's 1. Times the E equals A times D. So that's the 10 times the 1, that's 10. F equals B minus E. 12 take away 10 is 2. Print the value of F. Oh, actually, I just realized I should have written 8 there and 2 here. I've missed out that line. But now I'm sorted. Replace the B by the value of D. D is 1. B, so that becomes 1. If B equals 0, then stop. No, it doesn't. Otherwise, go back to line 20. And you can see this is just really trying to see whether or not you can follow through the instructions and follow those complex instructions. Calculate C equals B divided by A. 1 divided by 10 is 0.1. D is the integer of C, so integer of 0.1 is 0. E equals A times D. A times D is 10 times 0 is 0. F is B minus E. 1 take away 0 is 1. Okay, print the value of F. I've seen it this time. Replace B by the value of D. D is 0. If B equals 0, it does. I stopped this time. Okay, I've done it. That's what I was asked. to do. And I suppose what's interesting is what has that actually done? And sometimes you get asked this question, sometimes they don't. They haven't done here, but what I've printed 128, which is interesting because effectively my original number is 128, and I think this is all to do with bases. If 128, if you split it, you've effectively got hundreds, tens, and units. And I think that's what these represent, hundreds, tens, and units. But it's only that because I divided by 10. I suppose if I was in some other base, and those of you who've done binary, for instance, in computer science, you'll know that if I'd written 128 in some other way, I would have got a different set of digits. And I suspect that's what's happening. I'm not 100% sure. Luckily, I didn't ask. All right, the next question, it says OCR exam question. Now, this was again modified from June 2013's paper. So what's it asked me to do? It says trace this algorithm written by Holly using the inputs A equals 30 and B equals 18. So straight away it says input, I can write those numbers in, 30 and 18. And it says C equals A minus B. So 30 minus 18 is 12. I can do that. And then it goes, well, these three, I've seen this question before. These three are kind of like, you do end up doing one of them. Likewise, later on, you end up doing one of these. And it just goes around and you repeat yourself several times. Let's just see which one I'm going to do. I've got C equals 12. So if it's less than 0, equal to 0, or greater than 0, in this case, we do one of three things. So because ours is greater than 0, it says let D equals A. D then, I'm going to write it in a new line because I know this is complicated and they've given me all these squares for a reason. D equals A, so that's 30. And E equals B. E is equal just to 18 still. So that's a bit weird. They've just, from memory, and this refers to part 2, from memory, what that does is if they're in the wrong order, it puts them in the right order. So it puts the biggest first. And then having done that, it says let F equals D minus E. So D minus E is 12 again. So I'll put that on. Every time I do a new line, I'm going to put it on a new line. F, now, so I'm back to this, one of these three. I've still got a positive value of F. And F is greater than 0, so it says let D equals F. So my D is equal to 12. And then it says go back to step 6. All right, so when I get to here, I'll basically go back to here again. I think I'll broadly stay here now. So F equals D minus E. So F then, this one here, is D. 12 minus 18, well, that's a negative number, minus 6. So now it's a negative number. I'm into this one. F is less than 0, yes. D equals E. D equals, right, that equals 18. And E equals F plus D. Now my latest F is minus 6, and my latest D is 18, so that's 12. Okay. Effectively, that's just kind of seems to have swapped around again, but I'm not really sure. And this is, you have to have the guts just to keep on going with this. So so what did I do there? D equals E and E equals F plus D, and that's what I did. And then go back to step 6. So I'll go back to here, and it says F equals D minus E. So F, this thing here is D minus A, that's 6. So it went from a minus 6 now to a 6. And now I'm into one of these again. Now F is positive, so I'm going to use this one. F is greater than 0, yes. D equals F. So my D now is equal to the 6. And go back to step 6. It seems to be a bit pointless, this, and you might question this if this came up on your exam, but you just got to have the guts to say, no, I've done it right, I'm just going to carry on. F equals D minus E. So my F, new line, is D6 minus the 12. I've got a minus 6 again. Okay, it's negative, so I'm going on to this step 7. F is less than 0. Yes, it is. D equals E. D equals E. Then my last E was 12, so that's 12. And the E equals F plus D. F minus 6 plus 12 is 6. So what was that? That was E equals that. And go back to step 6, okay? F equals D minus E. F, which is this thing here, is D minus E. 12 minus 6 is 6. seems to be going round and round in circles. Hopefully I'm doing this right. So now I've done my f. It asks me again, which one is it? Well, it's greater than 0, so f is greater than 0. D equals f. D equals, this is 6. Then go back to step 6. Boom. Let f equals d minus e. My f is d. 6 minus 6. At long last, I've got the magical 6, which seems to be what I've been looking for all this time. D minus e. 6 minus 6, yes. And if then, having done that, it's 0, now I can go to this step 8, and it says if f equals 0, first of all it says f equals d. F is now equal to d, which is 6. Yep. Then jump to step 11. Step 11 says g equals a divided by f. Oh, there's a long time ago. My f is that. My a is 30 divided by 6 is 5. Okay. Yep. And m equals g times b. Well, that's g. 5 times b, 18. 5 18s are 90. Print the values of f and m. F and m. Yeah, so it's that one and it's that one. 6, 90. Crikey, that was a lot to go through. I can kind of speed things up a bit because I've already highlighted now for part 2 here. Describe what happens when you have them in. Oh, I see. I think I've written this down in the wrong order. I think that in the real question said 18, and this one said 30. So if they are in the wrong order, I've already explained, they basically turn them around the other way. So this first section here is all about making sure the first number is big and the second number is small. So apologies about that. That should have said 18 and 30, not 30 and 18. And what will f and b be when you get these two numbers? Now look, this all depends on you sussing what has happened. And so I suppose you, at this stage, are meant to look at your input numbers, which were all the way back with 30 and 18, and then look at your output numbers, 6 and 90. And I mean, as I said, I've a bit of an advantage over you in as much as I've seen this question before. But when I saw it, first of all, I started thinking to myself, what's special about 6 in terms of 30 and 18? And I thought, hang on a bit, it's a number that goes into both. In fact, the highest common factor is 6 of those numbers. Highest number that goes into both. And that made me think, hang on a bit, is this just the lowest common multiple? And the lowest common multiple of 30 and 18. Well, 90 is the number that both 18 and 30 go into. So straight away then, I kind of then thought, well, if I start with 12 and 18, and 8, sorry, my highest common factor, which they've called f. What's the highest number that goes into 12 and 8? Well, 4 sounds reasonable. And what's the smallest number that they've called it m? The smallest number that they both go into? And I was thinking to myself, well, 24 sounds as if it's the right one. So just by realizing what this thing does, I was able to do this. Look, so that's a couple of questions. We're going to look at a few more things for this chapter 3 and on all things algorithms. So there's a lot to get your head around, and eventually we'll practice the questions in the textbook. Thank you.